Very good evening, all of you. Am I audible? Can I get some responses as always? Hey, Hari, good evening.
Hi, Jaykumar.
Hi.
Yeah, audible, very much audible.
Yeah, okay. Let us also hear from our student, interns, participants. Guys,
Mhm.
are we audible? Hari has joined us. Very good evening to all of you. It's seeing some responses coming in. We have Shashmitra Mishra, Satik Halder, Nagamani Yadav. Very good evening, guys. Hope all of you are doing good. So, as folks are dialing in, today is a very auspicious day. I wish all of you a very happy Ugadi, New Year, Gudi Padwa, or Navaratri. I think it is known and celebrated in different names across the different states. And it is also the new financial year. You see, the March 31st, the financial year ends, and April 1st, typically yesterday, the new financial year got started. That way, new accounting, new beginning, right? So on behalf of Team Emertxe, I would like to wish a very happy Ugadi, Gudi Padwa, a new financial year to all of you. So whatever you do, you're aspiring for a job, or you are already doing a job, want to make more money, right? Or want to grow existing money, grow in your career, whatever your goal may be, may all your dreams and wishes come true. So very warm welcome, and very greetings from Emertxe on the Ugadi day. Okay, so I don't know if it's happened today. I never planned today will be Ugadi also, right? We planned later. I realized right today it's a very auspicious day. Okay, so thank you very much for all of you joining in. I still see people are connecting. Typically, as you all know, we give about 4 or 5 minutes for people to dial in. I'm just seeing people are connecting, numbers are increasing. Very good evening, Mohan Krishna. Good evening, Afsal, Ganesh. Happy Ugadi, Ganesh. Good evening, Abhishek. Good evening, Harsharaj, Abhishek. Ganesh, Akasali is telling wish you the same, sir. Okay. Best wishes, greetings, Ganesh, on Ugadi to all of you guys. Ajay, thank you, Ajay. We have Sauntarya, Shailaja. Good evening, Shailaja. Raghavendra. Best wishes, Raghavendra. Wishes to you also. We have Diana, Sahiti, Snehal. Good evening to all of you guys. Couple of more minutes, we'll get started. Sahiti is she's wishing happy Ugadi. Happy Ugadi, Harshraj. I think typically we make something called pachadi. I don't know what you call in different languages. Something like a mixture of sweet, sour, and bitter. I think all of you eat that to not only celebrate the festival and also understand that's what life is all about, right? So all of you had a good lunch today, a special feast due to Ugadi, Ugadi Pachadi, etc. At maybe another minute, then we'll get started. So while we are waiting, can you just let me know the category of you guys, means from where you are from? You are a student in Emertxe, and type student, and then if you are from intern, you can type in intern, or if you are a new person joining in, you can say newbie. Can you type that? Mohan is a current student, of course, or regular participant in all our webinars. Thank you, Mohan. Okay, we have Diana, our international intern from webinar. Intern from Lebanon. Sorry, Sakiti from current this thing, and then Ganesh is an intern. Sanjit is an intern, sorry, student. Sauntarya is a student. Student in Emertxe says Satik, online classes, 3 classes till now. Current student from Kanyakumari says Afsal. Good number of your students today joining in, looks like. And Bhunesh, a new joining, new student. All right, good. Kannan, Raghavendra, student. I think larger today we could see the student community coming in. Maybe we'll also see the open, because as you all know, these webinars are open for everyone outside Emergey also. Let us see. Okay, Rajeshwari, Chidni Banu, Ashutosh Ranjan, and all student. Glad to see many of you from the student joining in. Linux module is going on, says Satik. Okay. That's why we are here. Okay. Not necessary, Satik. This is beyond that. This talk will cover much more than what you're currently studying. Okay. Venkatanagendra is telling hi, sir. Hi, Venkat. All right, folks. I think we are 7:05 now. Let us get on to our flow. Let me minimize and get started with the slide or regular template. All right. So very warm welcome to all of you for the third Masterclass webinar. We started our new format of Masterclass from the month of January. We started off with what you call as a emerging technology series, where we are going to talk about more of technologies which are emerging or going through rapid transformation. So in this regard, we are having the third webinar today, and today is 2nd of April. Okay, so very warm welcome to all of you. And a majority of your students, but still quickly, I'll take a couple of minutes to introduce Emergey in case any intern or a newbie coming and joining this particular webinar. As you all know, Emergey is a tech company. We have been in this education field for the past 18 plus years. Majority of you in the call today are students going through our embedded systems course or our IoT course, either on the daytime or in the evening batch, online, offline, right? We have a combination of all of that in this particular call. Then as an organization, we are trying to solve two challenges. One is like to building skills. We are making people employable, getting you guys placed with core companies. I think the recently joined students will be able to relate. A lot of placements happening, right? All the core companies recruit our students. And the other part is about the upskilling, where people who join our course, right, after they gain some work experience, they want to achieve career transformation. In the recent past, last few weeks, I would say we are seeing more success stories coming from the upskilling also, where they come from a different domain, take our course, and then achieve the career transition. Okay. So that's what Emergey for people who are new, right? And part of the leadership team, three of us, Mas, who is the founder and managing director of Emergey, and myself, one of the core leadership member, okay, who run all these, end up meeting a lot of you guys in the webinar format, right? And we have Mubin, who is our technology head, leads our entire team of mentor, right? Some of you might have met him, especially the offline students, right? And people who are familiar know, right, we are more known for placing students in core companies. Pretty much all the companies in the automotive, semiconductor, telecom, aeronautics, consumer electronics, IoT, robotics. So that's a field of companies, right, who hire our students. Good number of them are already placed in these companies, and every day we tend to see larger number of organizations hiring these students, hiring our students, and they're all becoming successful in these things, right? All right, let us get into this. As always, what are the reason for this webinar? They we always consider two M's. One is like to get mentoring, to get experienced people from the industry who are working in the core segment, who bring in a deep technical expertise and come and share their experience, right? So this is all not typical Gyan giving sessions. It's more of them, their real-time experience sharing, and making it as a two-way interaction among you guys. People who are attended in the past webinars can relate. A lot of questions come in from our students, right? That's one thing. And when they present their learnings, right, one of them is planned for today, right, about the topic of Linux. When you understand the big picture, how things work, automatically we all get motivated, right? That's the second or the other benefit that we would like to see during our webinars, right? Okay. With that, let us get into today's webinar. Today's webinar is very special. If you look at the past two webinars, we spoke about the electric vehicles. The emergence of electric vehicles for the first webinar in this masterclass series. And last one was about how the machine learning and artificial intelligence getting applied, especially in the context of edge computing, right? But if you look at those two topics, they're probably on a kind of high level, talks about more of a trendy things, right? But today's topic is something considering that most of you are our students, right? You all should be able to relate because we are going to talk about a very interesting and very relatable topic called Linux, right? Unleash the power of Linux and what makes Linux powering Netflix to Android phones today. Okay. So looking back, I would like to add a couple of points before I open the discussion for our, invited our expert speaker, Mr. Hari. Right, 20 years back, I was introduced with this boring black color terminal called Unix, and say go and type a command, right? Like all of you guys, like I went and typed an ls command and pwd command. I was all wondering, how does it going to matter, right? Then slowly started, seeing transformation where this Unix, right, started taking a shape of Linux, even though there's a lot of difference between them, right? Started getting into GUI. That's when we used to call it as a X window system. And those days it was all assembled computers. So one of the hack that we used to do was how to get a X Windows working in your desktop or a laptop. So that was a very challenging and an accomplished task if X Windows works on your desktop, right? I tried multiple times. I failed. Finally, in my first Celeron, processor, I was able to get the Windows up and running, right? Then later the transformation started happening way faster than all of us could imagine. For example, the Ubuntu came in and it entirely changed the way how a look and feel of Linux works, right? And all of you guys, especially you being Emertxe students, will be able to relate because you use Linux day in and day out, right? So this is one part of story, right? Second part, if you look at today, day-to-day basis, when I use a particular technology, for example, I get up in the morning and I see my WhatsApp messages in my phone. My phone is powered by Android, which is nothing but Linux, right? And I try to do anything in my phone. I try to basically do something in my social media, or I'm trying to do some commerce, or trying to do some game, or the OTT like Netflix or Amazon. When I try to watch some movies, everything that you can think of is powered by Linux, right? Majority of you may not be aware of. That's one of the reasons why we brought in this topic, right? So okay, so this is a whole paradigm how Linux has completely changed, from a boring command line driven operating system to powering everything that you can think of, right? Today, for example, cloud computing majorly, be it an Amazon, AWS, Microsoft Azure, you name anything, or open source based cloud computing platforms, everything is powered by Linux, right? So Linux is everywhere. So that's going to be today's topic, right? For which we have our expert speaker, Mr. Hari Krishnan, he's a principal engineer in Broadcom. Let me briefly introduce him before we open up the talk for him. So he's working in Broadcom as a principal engineer, and Hari is having about 19 years of work experience with deep expertise in Linux. Okay, predominantly his career in the past 19 years is spent with Linux, working in various aspects. But his specialization lies more on the performance enhancement in the low-level device driver and the NVMe driver. Okay. And before his assignment with Broadcom, he was working with a company called InImage, where he developed some solutions, drivers, which is acquired by Microsoft and which is powering Microsoft's Azure cloud. The point which I was mentioning previously, right? Today, you name about any cloud computing, it is touched by Linux, right? And Hari has been part of those building those innovative products which are part of Azure cloud, right? And today, if you look at, Hari is a man to go for all the drivers that you can think of, name it fiber channel, networking, virtualization, file system, cluster file system, block device drivers, iSCSI or SCSI, right? He has extensively worked on low-level firmware, device drivers, bootloaders, right, bring up, etc. So people keep talking about the vertical and horizontal specialization. So Hari is one of the very few experts that you can think of, right, who has been in that low level, layer just above the hardware, working at a driver layer for a long period of time. Okay, so that's about Hari. And on a lighter note, he's a very good friend of us. When he's not spending time with Linux, so Hari is found closer to the nature. He's an avid trekker. He likes to climb all the mountains possible, right? And I am not as athletic as him, but we share a common interest of exploring new places. And he promised me that he will take me to Jerusalem for free, right? Okay, Hari, I added the word free, okay, right? So Jerusalem is a historical place. That's where we connect, right? So thank you very much, Hari, for accepting our invitation and being part of this particular webinar series. It's a pleasure having you. Okay, so I would like
Thanks,
to
Kumar.
change you as a presenter. Give me a minute.
Okay.
Sorry, are you able to? Okay, all
Yes.
right. Okay, one more thing before I hand over, guys. As always, please feel free to ask as many questions as possible. Like in every webinar, we say no question is wrong question, no question is stupid question, right? About Linux especially, it will come to me. What I'll do is like always, once Hari covers certain set of topics, I will pause by and I'll ask, put across your questions on your behalf, and Hari can answer, and then we can proceed, right? And end of the quiz, as always, we have a end of the webinar, we have a quiz. We'll share a coupon code you can use and take up our Instagram quiz, and the winners will get the goodies, right? So that's what it is. So I don't want to be in between you and Hari, so I'll go off the video now and let Hari take over the slide sharing, and I'll connect with you towards the fag end of it. Anyways, I will attend. I'll also take some notes and get some learning as well. Okay. So thank you very much, guys. So let me go off the video and over to you, Hari.
Yeah, I think you can hear me, right, Jayakumar?
Yes, yes. Yeah. You're audible.
So, hi
Go ahead.
everyone. I think thanks for lovely introduction, Jayakumar. So today we are here to see unleash the power of Linux. Okay. So I'll without mincing words, let the picture talk. And this is what I have when I say unleash the power of Linux. So here, if you have seen movie, it's a very famous movie and very famous character, Thanos, and he's holding infinite stone. And as you can see, right, it's the imagination, just the infinite stone can be, Linux can be powering infinite stone, or someone who understands or someone who knows in and out of Linux can be as powerful as Thanos, or maybe have powerful which infinite stone has. Okay, so that's anyways the movie story. So today we're going to cover, to understand this, or how is this possible, today we're going to cover something called OS Basic. So we'll see the introduction of OS Basic. Why? Because Linux in general, when we know Linux, it's an OS. Okay, and then why Linux is so powerful? I think some of it Jayakumar already touched, that Linux is omnipresent. Okay, so what is the reason behind it? Why Linux is so powerful? And then we will look at introduction to Linux internals. Why we want to see Linux internals? Suppose you have some aspiration or you want to learn more in Linux. So internal is one of the entry point where you can start digging into Linux. Linux is like an ocean. Once you go, it's vast, you can get lost. But the entry point is Linux internals. Once you know, probably things will be smoother. And then we will start something called Netflix Linux Performance Case Study. Okay. So we'll just get started. So what is an OS? I'm sure most of you may know what is OS. For those who don't know, as a definition, OS is a software that acts as an interface between application and hardware. Well, it's an abstract between hardware and user. Why do we need an abstract, or why do we need a layer altogether? To know that, let's assume that this is your hardware, okay, and you have OS, and OS we all know as a Linux, Android, and Windows, and iOS. So you have a hardware, you have OS, user or an application will be sitting on top of it. So that means there is an abstraction, okay, abstraction between hardware and the user. Why do we need an abstraction? Okay, or very first place, why do we need an OS? Can I live without OS? Maybe you can, For that, first you should understand why we need OS, or you should understand the hardware we are dealing with. So basically, this is the hardware, as you can see in my screen, right? So this piece of diagram could be scary, and believe me, even I am frightened looking at this diagram. But this piece of diagram is your hardware. So this is an Intel Ice Lake latest model. So most of your laptop may have something similar block diagram. I mean something similar hardware, and even your server desktop, I mean, name it. Most of the servers will have something similar. So if you see here, this hardware has various components. One is processor, which is CPU, and then you have RAM, you have PCI slots, you have motherboard, you have some more PCI slots, USB controller, then you have LAN, then you have some more, connectivity. So all these are hardware. So imagine, just imagine that you have to write a simple program. The program is Hello World. I'm sure most of us have written that program. So a Hello World in C, or you can write Hello World in Python, Java, whatever language you like, you're comfortable with. So can you imagine, without OS, you have to write Hello World. So to do that, first, you have to extract the code, right? You have to extract the program or code. So for that, you should understand how to interact with the hard disk and how to interact with the motherboard, right? So you have to write a code for motherboard, and then you have to load that inside the RAM, and then the code will do print, right? It's going to print hello world. So while printing, it's again need to send some information to a display, right? So display can be your monitor, it can be your graphic card. So again, you need to understand, okay, as a programmer, as a coder, you need to understand how to do that. So imagine all these things you have to do if there is no OS. Well, thankfully, we have OS. And here we are just discussing why we need an OS, right? So just to give one more view, suppose this piece of diagram is your laptop. OS makes it look like this. So it will make your OS, I mean, it will, so all the complexity OS will take care. So for us, it's a lovely picture, it's a lovely interface. All we need to know is how to use Word, maybe Excel, maybe how to use the browser, Firefox or Chrome. But beneath, in the background, there is a complex hardware, which OS will take care. Similarly, here you have a mobile. So mobile hardware is like this. OS, it can be Android or iOS, will make it like this. So this is how it takes care of complexity. So as a user, we might not realize the complexity behind this piece of hardware, but as a programmer, or especially when you're getting into the core end of it, when you're trying to understand more into it, so it's makes sense to get into it and we understand what exactly going. So let's take one more example here. So let's say you have multiple users. So I have user 1, user 2, and user 3. And all three wants to access different applications. Here there is a browser, compiler, and file access. When we say file access, we can say a Word document or maybe direct file access. But all these are, for us, is a program interface, right? So there is a program, it's an application. Internet's a program and it's a program interface. But do we really concern that how this browser or say this compiler will access the hardware or the resource? Maybe not. Why? Because we have an operating system. So operating system provides an abstraction from the hardware, so that if there is a file access, it can directly access your hard disk, right? So this is a very simple example and very simple way looking at the OS. So is this the only thing which OS will do, or we need OS? Well, that's not the case. So abstraction is just a one part. OS does many more things. Okay. Along with the abstraction, OS will do resource management of all your hardware. When we say hardware, it can be number of CPUs. Nowadays, you may see that you talk about multiple CPU environment, and you talk about RAM. So RAM is end of the day is a resource. And you have multiple resources like USB drive, and few other things. So to name few, let's see what these resources are, right? How it does. So we can say CPU management, which is nothing but scheduling, and then you have memory management. Again, it's for memory allocation. When we do deallocation in C program, you do malloc, you free. So indirectly that we call malloc, but what happens if we directly call malloc and indirectly it goes to the memory management, and that's what happens, and it will do the allocation. So similarly, you have various component like process management, which will do a process management. You have IO management, and then you have a user management, which will do user management, like multiple user can work. You have file management and error management and many more. Okay, so OS, you can't define OS in just a simple plain definition. OS has a lot of things. So one of the key component is abstraction and resource management. And when it comes to resource management, there are a lot of things. Okay. So, but if I have to define OS in two major functionality, probably I will pick two things, and that's how even industry picks. So one is hardware abstraction. So hardware abstraction is in terms of your GUI or CLI. When we say GUI, we all watching this webinar on a laptop or on a mobile. So that's a GUI interface, and you even have a CLI interface like Bash. Sometimes we write our program in Bash, we run scripts. So all these are CLI. So CLI and GUI is a major part of OS, which is a one part of it. And then the next part of it is the resource management, which is a management of CPU and other things. With these two combination, we can achieve something called multitasking or multi-programming. And this piece of resource or hardware resource management is called kernel. And we have something called Linux kernel. Okay. So this is called kernel. So now we will see what exactly is kernel. So all these things are applications. I'm sure most of you are familiar. Here, like you have SSH, you have GCC, you have Firefox and Bash. So all these things we are familiar and we have used it. But as I said, in background, you need far more, right? For Firefox, it's a browser. For a browser to work, it need to access your network. It could be your Wi-Fi card, it could be your hardware LAN card, something, and it need to do some of the networking protocol like TCP/IP and few other things. So some of this hardware access Firefox will not do. Instead, there is a kernel component. Okay, for each of these functionality, there is a kernel component which will actually serve and do all the complex work. So you can see few like process management, memory management, file system, device control, and networking. All these things you can say it's actually low level and it's part of Linux kernel. So that is what the kernel is. So above is an application which we all know, which we deal mostly, and below is the kernel. And kernel not only will give these features, it will also access the hardware. Like for process management, most of the hardware part is CPU. For memory management, it's a RAM space, whatever the RAM space we have, it talk about that. And then you have a device control. Device control is something we have keyboard. So you can just imagine like you have a mouse, you have a keyboard. So whenever I click something, so your device driver gets into act. Okay. Suppose you are waiting on some event, like whenever you say press A to continue, press B to continue. So there is a device involved, and when we press something, that interrupt goes. We will see that. We will see what is interrupt and how the device works. So this is in a nutshell a Linux is. So let's dig little deep into it. We know what is Linux kernel is, what is functionality is. Now we will see what exactly we are talking about and how to even access or how to even know. Okay. So as you all know, Linux is an open source. In fact, this is a major reason why Linux is so powerful. And Linux is under GPL license, so that means you can access it, you can make modification. If you do any modification, you have to make it open. So if I take it and if I add some value to it, I can't keep it to myself. I have to make it open. I have to contribute back. So that's how it works. So because of this, it has evolved. As Jay Kumar said, in early days, maybe 20 years back, it was only CLI component, and we used to even struggle installing it, and we used to see some issues as well. I mean, if you want to have some tool, we will really struggle. But over the period, since people started using it, people started liking it, and it's open source, we all started contributing. So everyone who is using it and they are developer, they can contribute. So that's the beauty of Linux. And you can get all this code in kernel.org. So you can download that code. You can just build that code. We will see what it looks like. So you can even browse a code. So there are various browsers available. I mean, Linux browser, even kernel.org gives a Linux browser. And I typically use this Linux browser. So let me show you how it looks. So before that, we will see how directories are. Okay. So then I'll show you how the browser looks. So if you download a Linux kernel, let's say, and you open it, you have to get a C code. Okay, and what you will see is there will be various directories. So there will be arc. Arc means architecture, like you have various architectures. You have Intel, you have AMD, you have ARM, you have PowerPC. So Linux kernel supports various architecture. So they have kept all this architecture specific in one directory. And then you have something called scripts, which will take care of how to manage this code. Then you have sound. Obviously, sound means something related to sound. I'm talking, so it's going via sound driver. And then you have a file system. File system is, again, it's related to storage. Mind you, when you plug in any USB drive, your drive gets into it and there is a file system. So whenever you want to read, you do a file system access. So basically the OS and the kernel is doing, and that piece of code is inside this FS. And when we say few other things like inter-process communication is here in this directory. And then if you want to look at something related to network, like Wi-Fi network or maybe a LAN, so that will be here. I'll show you a code just to get an overview. So this is a browser, okay, and this is how a typical Linux code looks. Linux kernel code. Okay. So as I was referring, FS belongs to file system, and there is a, as you can see, this is very famous nowadays. Because of the Bitcoin. Believe me, in Linux it was there. We were playing. All the Linux users or the kernel developers, they were playing with this. So it's new now, but the code was there. So now the applications are immense. You have Bitcoins and you have various things. So I'll do one thing. I'll go to this directory just to show how it will look. So here you can again see various directories, like you can see ext2, ext4, and there are few other file systems. I'm sure few of you may know this are file system which is native to Linux. It even has NTFS and few other file system. You can even browse some of this code. Like suppose I want to, let's say, browse super.c, which is nothing but a super block here. So I can even look at the code. I can browse. So don't worry, we are not going to browse today. Now we're not going to get into the code because this is something it's little advanced right now if you are newbies. But the point here is whatever we want to do, it's already there. It's already available. The code is there, and same thing goes with the industry. Okay, so suppose right now I want to load this Linux on my smartwatch, let's say. Okay, so I can modify some of this code, I can modify some of this driver and build this Linux kernel and load it on my watch. That can also be done. In fact, nowadays, few of the drones, they work on Linux. Smart drone, they work on Linux. So they will modify their drones software. They will modify specific to that drone. There could be some driver which may not be here. They will load it. They will code it. They will load it, and they will run it. So that's why Linux is so powerful, and that's why Linux is omnipresent. So whoever want to change, understands it, they can really use it and make changes. So today we are not going to do that. My idea is to just show why Linux is powerful and why it's so adaptable. Because it's very flexible, right? You can even change the code, right? So this is one more, I would say, scary diagram, okay? But again, the point is you need not worry about what this information is. But if you dig deeper into Linux code, suppose you dig deeper into Linux code, you work on it, and you understand the code, so you can understand the mapping, how various component works. And this is something very important. Why? If I talk about Windows or AIX or maybe iOS, you can't get this information unless probably you are working with Microsoft or Apple. You can't get this information readily available. But whereas in Linux, you can go and read the code, you can run the code, you can put some prints if you want, you can do all sorts of experiments, and there are a lot of open information available, like these, how various component interacts with various other components. So this is what makes it very powerful. So you have all the information available, all the tools available. Okay. So now the question comes. Yeah,
Sorry to pause you. There are a couple of questions here. Maybe you can take and
sure.
then go to that.
Sure,
Okay.
Jaykumar. I'll do that.
There's a question from Ajay Kumar V. He's
Mhm.
asking, what is principal engineer? What do you do? Right? Like in
Oh,
your,
that's a
maybe you
nice
wanted to know
question.
about your career, right? Right. So as a principal, in fact, I get this question in every monthly meeting when people say, I want to grow technically, become an engineer, senior engineer, and suddenly they see I'm a principal engineer, right? What is your day to day? How your day looks? Probably that's where Ajay's question. Am I right, Ajay? Is that what you want to know? What does Hari's day looks like? Maybe that's what you want to know, Ajay.
Well, my
Okay, go ahead,
day,
Hari.
okay,
Yeah, I
my
think
day
he wants
looks
to know what you
as
do.
simple.
Yeah,
Yeah, I
yeah.
got it. So on a lighter note, my day looks as common as other people. I also probably the first thing I'll open maybe the WhatsApp or the Facebook. But when it comes to the business, yes. So every day there will be some challenges. Like we have the driver, which we support, and what happens is every day we get some challenges, like we have to enhance something, we will try something, next day we will come and we will read the data and we will again change. So there are various things which we will do, like as a principal engineer, we might have to deal with a customer escalation because our product is up there running and suddenly there could be some issue or some explanation which the customer want. Sometimes we might have a feature, we have a problem to solve, and we need to solve that problem. Like suppose, just to give an example, on particular setup, like as you said, performance enhancement, on one particular setup, I'm not getting the desired output. Like program is working as designed, but it's not giving the exact, the output is not fast. I mean, imagine you're watching a live match on a Hotstar, and there is a lag of 10 minutes or 5 minutes. Okay, so you don't want that, you want it to be fast. So that is what nowadays everyone wants, fast. So that is what, one of the challenge, how to make things faster, so for us, that is what it is, we want to make things fast and fast, because we want to extract everything. I mean, like nowadays with the changing world, everything is becoming fast. The processor speed has increased, bandwidth has increased. So that is what my challenge is.
To summarize what I understand, Hari and Ajay, to answer your question, right? It's all about solving technically complex and challenging problems. That's what is career day looks like. Hope that clarifies, Ajay. And there's a question from Rishikesh PS, Hari. He says, does a server has any screen? Why do we use Linux for running a server? Why not other OS? What are the disadvantages, right? his question is why server is we are using Linux, and do they have a screen or the UI? There are two questions.
That's a very good question. Let me answer first. Why Linux is used in the server environment? So so that is what Linux is powerful. I mean, powerful in the sense we over the period it has evolved, right? 20 years back it was a different OS, probably mostly an experiment OS. We used to feel good, wow, we can do this, try that. But then it has evolved, like the company called Red Hat, SUSE, all these, they want it to work very fast. As I was explaining, my one of the core challenge is problem solving is how to make it fast, fast on the faster servers. So when we talk about servers, Jay Kumar, so we are talking about CPU of 200, 125, 200. Even there are some CPUs, number of CPUs which can go up to 1,000. Yes. And we talk about, I mean, the RAM around 2 TB, 1 TB, 2 TB RAM. So if you have a good hardware, you need to have a very good and sophisticated software. So Linux actually fits there. And so that's why, Linux is preferred. So Linux has, and Linux, there is one more thing, they do a lot of benchmarking. I'm just going a little technical. So what happens is there is various benchmarking. When I say benchmarking in layman term, a lot of testing other company does, and they publish that. And that brings a confidence that yes, this is best suited for my server. Second thing is cost. Nowadays everything is cost. So Linux comes free, sort of. Even if you install Red Hat, it comes free. Probably you need a support, and a few other variants also comes free. So all these thing comes free, and everything is good. So why would you go for anything else, right? So that is answering to the first question. Second is, do server has screen? No, actually, server may not have screen because usually what happens is that this is mostly because of the space, rack space or the space. So what happens is server is it can be a box or something. So the idea of server is serving, remotely it's serving. I mean, whenever we are doing Googling something, it goes to a server. Whenever we browse something in the Facebook, it goes to a server. Okay. So server is serving. So no one in the data center or in the lab is looking at that screen. So we don't need a screen in the server. Okay. So what happens is that's why they don't keep that screen, just to remove the hardware space, and they make it lean so that it fits. So server will not have a screen, but there are various ways to connect the screen. I mean, probably they will have HDMI connectivity, or nowadays you have a different way of connecting. You can have an IP where you can connect to that servers. I hope that answers to that question.
Rishikesh, are you getting the two questions you asked? Why Linux is used in server? That was your question number one. Second one was, about, does that server will have an UI or not? Okay, all right. Rishikesh is confirming. There are a couple of more questions, Hari. One is from Raghavendra, the next one. He says, Hari, you told Linux is open source and we can modify the code and run. But why all laptops and desktops was installed with only Windows? Or rather, why Linux is not so popular in desktops? I think that's a very interesting question also, right?
That's a very good question. And let me tell you again, it's probably, my question could be partially correct. So it could be something to do with the economics of it. Like I'll give my example. So when I ordered over Amazon, mostly you will buy it over Amazon, or you will call your friend in somewhere in US where you can get it little bit discounted rate. So normally it comes with the Windows installed, right? Or the cost will be very less, and you are used to having all the component of Linux. It's just a comfort. But whereas when it comes to Ubuntu, right? So earlier, I'm talking about 10 years back, probably for laptop we would use Windows only. We will struggle with Red Hat. We may not like as a GUI. But with Ubuntu, I see a lot of adoption, and even in Amazon, I see there is a Ubuntu-based laptop. It means it pre-installed Ubuntu comes, and the rate is less because when we buy a Microsoft-based laptop, means Microsoft installed laptop, it will have few extra money, you are paying, although the delta is not that high. So I think it's more of an economical reason and user choice. So what happens, Jaykumar, is since we are into development or we are into technology, we understand Linux. So again, you're going through this session, you understand more how the Linux works and how powerful Linux is. But whereas as a user, as a layman user, as a student, let's say, they may go with the first choice or a popular choice of laptop. So at present, the popular choice of laptop is Windows. Whereas if you go abroad in US, the popular choice is mostly the Apple one. So that is what it is. So it's mostly driven with choice and but nothing stops using Ubuntu on a laptop. In fact, many of my friends, they use that.
Is that clear, Raghavendra? It's more of user adoption, and there is nothing that stops from anybody using Linux in their desktop or laptop. Okay. And there's
Yeah.
one more thing.
I just want to
Hari,
add
before
something. I mean, like one story. 10
yeah.
years back, my laptop, we were just experimenting, me and my friend. So my laptop had, I think, Red Hat or Fedora. So we were not, I mean, we were struggling to play the music. It was very difficult for us because there was some plugin was missing, and it took almost a week. But from there to now, Ubuntu, it's so easy. You can install a lot of apps, and you need not struggle. I mean, everything comes pre-installed and everything is there. So I don't see any reason not using Ubuntu.
Great. There's one more very interesting question, which is also comes to our mind. Is from Drupajyoti Sharma. He's asking, is Linux more secure than other operating system? If it is, why? What makes Linux secure?
That's a very tough question. Okay. So is Linux secured? Yes. In fact, recently, every 1 month they release a security patch. So basically, security is a vast topic, and thankfully I have worked on security, so probably I can touch some light on it. So Jaykumar, the security is two aspects. One is the hardware and the CPU. When I say hardware, CPU. So recently, there was one issue where there is a branch change. When what happens is you have a processor. So each time you call a function or function pointer, there is a branch change, inside. So these hackers, I would say they are really smart. They are one of the smart people. So they understand where is that vulnerability, and they will try to explore that. Okay. So what we have seen is in practice, what we have seen is exploring those vulnerability is far easy, uh, or I can't say, probably statistics may say that, but in Windows it can be done, whereas in Linux, even if it is done, it's not that easy, because you have something called secured Linux. If someone is using that secured Linux, it's very difficult to do that, and on top of it you have a lot of patches. That is one thing. And second thing is, I mean, let me put this question different way. Linux, the source is open. So will there be a security, problem because everything is open? But that is not the case, because the security aspect is not a static one. It's actually a runtime. Means runtime, either you are changing some key. I don't want to get into too details. You change some key in the packet and you sniff into it, some token you change, or you actually change the instruction pointer somewhere where you have a branch vulnerability. So Linux actually takes care of all these things. That doesn't mean Windows doesn't take care of it, but problem with the Windows is you might have to buy antivirus software or something, whereas in Linux you don't need to. All you have to do is just update the kernel and OS.
Because I always tell in my earlier, I used to do some Linux classes. I always tell this as an example, what you concluded, Hari. You would have never heard about antivirus for Linux, right? None of us have
Correct.
heard. Whereas we keep hearing about various antivirus, etc., etc. So one is like you upgrade the antivirus software. Rather, in case of Linux, the kernel itself will get upgraded thanks to open source, and many of them are continue to put
Correct.
patches and things like that, which makes
Correct.
inherently, inherently more stable. Another easier way to put it across to this Dubajoti is that one is like, are you inherently having the what do you call the immunity, or are you taking extra antibiotics to keep your immunity high, right? Okay, Linux is inherently I know thing because it keeps on upgrading, right? Windows is something where you eat antibiotics and keep your your what do you call your immunity high. So that's another way to look into it, right? So anyway,
That's a
so
very good example, Jaykumar. Yeah.
right. So there are a few more questions. Hari, you wanted to take it now and then move on, or you wanted to pause and take
Sure,
it
sure. We
later?
can take one more question, then we'll
One
proceed.
more question. I think then we will come back again, because I could see again Rishikesh typing in. We have Lanvin D'Souza typing in. Vishesh, Ravi, Drupajyoti, right? Quite a lot of guys typing in. One more question before we proceed. Then we'll come back, ensure that all the questions are answered, right? There is this question again from Rishikesh. He's asking, does all applications working in Windows work in Ubuntu?
No, no, no. That's not true. I mean, like, it can work. So for that, you need to see what happens is, again, it's little deep. So the binary format is little different. Even if you see the file extension, right, there you have a exe, and here you have a a.out. Okay, so that is not only one difference, so how the OS loads and how it runs is different. So probably you can use, something called Wine. If you have heard, you can use that. uh, but that's why, I mean, so answer to your question on a simple plain way, no, Windows application will not work on Ubuntu straightforward. You have to do some changes. So that's why the C is, a C program. So what happens is, you have a program, okay, you write such a way, when you compile on Windows, it will work on that, and you compile on Linux, it will work on that. So that's why you have a C, right? So if you're using only plain C program, chances are 99% it should work, unless you have not used any, Windows specific API. Let me put it this way, Windows specific libraries, which is not available in Linux. Okay. So if that is the case, you have to just compile and run it. That's a far easy and better way. So that's how even industry works. As an experiment, probably you can use a Wine, but I would not suggest do that, because there you may have some problem, because when they do some conversion, right? So there could be some problem, and even the performance problem.
All right. So not all of them will work. So thank you very much, guys, for asking questions. I can still see more questions coming from Naveen, Kumar, PR, and Ashutosh Ranjan. I think let us pause it. Let Hari continue some more slides, and then we will come back to the questions, right? So really
Sure,
appreciate.
sure.
I'm really happy to see so many interesting questions coming from all the directions. So please
Okay,
let
sure.
them keep coming in, and we'll ensure all of them get answered. So request you to proceed, Hari.
Yeah, you can stop me anytime, Kumar.
Yeah, sure. Yeah, yeah.
All right. So let's continue with our discussion. So we were just discussing same Linux code. Okay, it fits on supercomputer, smartphone, laptop, and real-time system. For those who don't know what is real-time system, so real-time system is could be your drone, or it could be your car. Most of the embedded systems. So how piece of same code can fit? Answer to that, we already answered it. You can modify your Linux code. Uh, Suited, you can do a custom modification suited to that kind of environment. You can remove some of the codes, you can tweak, you can make it lean, you can make it heavy as well, depending on your requirement. So that's why there are various projects, or I would say various companies like Google. Google started using Linux, and they started using us in the Android, and actually it has paid really well, right? And you can find that code here, right? So Google, I mean, Android specific kernel, although it will be almost close to what the original kernel is, but there will be some modification, some difference, which is customized for your smartphone. So not only the smartphone, Android even works on your smart TV. Nowadays most of the smart TV comes with Android. Even your car display comes with Android. So chances are that Linux kernel is running and those are modified kernel, and code for that will be here, right? So anything Android, and if it is kernel, the code will be here. So what I want to say is various company or various organization or even individual can take that kernel and make changes and suit for their own environment, right? So something similar even Red Hat, SUSE and Ubuntu do. So what they do is they will suit for the environment, like they will do some performance enhancement or a few other things, okay? And as a GPL license, they have to keep it open and they have to give it back as well, okay, to the original kernel.org. So these companies have contributed a lot. They have their own source. So whenever you install Ubuntu, Red Hat, they will have their own kernel source, which is on their website, which are custom made, okay, custom modified. So that's why you can have a different kernel, okay, running on smartphone and maybe on your laptop. And on top of it, you have something called scientific Linux, okay, so which will cover your supercomputers, okay. And not only that, nowadays medical has advanced, and with this COVID, we know, there's a lot of science and AI into medical, and some of the smart computation is done using scientific Linux. Not only that, world's one of the advanced, particle physics lab, which is Fermi Lab, chooses scientific Linux. It's a very big deal. I mean, for those probably who don't know what is Fermi Lab, this is a block diagram, small, diagram what it does. So it's a particle physics lab which has a big, which has a huge energy concentration where it actually bombard the particle. They will analyze all the particles. Okay, so Linux is used there, and whenever whatever they want, they can achieve using scientific Linux. And beauty is if they make any modification, they have to keep it open. So all that source is here. Okay. So now the question comes: how do I understand Linux in and out, and unleash the power of Linux? For that, you have to become a Spider-Man. Why? Well, with great power comes great responsibility. You might have seen movie. If not, I will encourage you probably go and watch some of the Avenger movies. So with great power comes great responsibility. What that exactly means? Well, that means you have to be a good programmer. Okay, when I say good programmer, when we write some program, sometimes you get a segmentation fault or some gets hang. So those are okay, as an experiment, but you need to understand more. You need to be a very good programmer. You need to understand the code. You need to program well. Okay, and then good in C. Why C? Yes, you can even be good in Java, good in C++. But C, if you want to be good in low level part of Linux. So majority of Linux code is in C, and I would say Linux kernel 95% is in C. Okay, and some of the tools are in C or C++. Majority of tools are in C or C++. It can be even other tools like Python is used nowadays, Java is used. But having C is best. Then usage of basic commands. So you should know how to use. So as an engineer, we should know how to use tool, right? So there is no denial. Engineer means we should know how to use tools. So tools are best available in Linux. So some of these tools could be top, yes, to look at the process status, stress, and many more, right? And then probably we are getting into deep, you want to understand the process, it's not processor, I'm talking about process. We'll see what process is and system call and how it works. And then, you have more interest, more energy, understand the internals of each components, right? So there are various components which we just saw a while back. So we can, so it's a step-by-step approach. You need to understand, you need to be a good programmer, you need to be good in C, then you should know how to use basic commands, maybe then advanced commands. Then you slowly get into using, understanding the system call, and then probably you can unravel the component, right? So we will start with interrupts. So now we are getting into the business end. Okay, so most of the stuff what we discussed was on high level. So now we will start with the interrupt. So, okay, I know what you guys may be thinking. Okay, now I'm getting lost. What is system call and what is interrupt, right? which is right. Even when I started this long time back, for me, this was alien words. What is interrupt? So don't worry. So what I'll do is I'll present a simple story. We call it an ice cream story. To just understand and correlate the interrupt with our life, right? Imagine that you're working, right? You're working on a laptop, your desktop, doing some programming or something, okay? And it's hot day, and you want to have an ice cream, okay? So what you will do is you will order online, and you will make the payment, and you start working, okay? And you will resume your working. So while you're working, in a while, maybe after 5 minutes, 10 minutes, your ice cream will get that order, and it will be on the way, right? And it will take some time to come. So once it comes, the delivery boy will come to our doorstep. Okay. Then what next? Probably he will knock, right? He has to ring the bell and he will knock. What is this knock knock, right? So this knock knock is nothing but an interrupt, right? Interrupt to you. So you're working and you suddenly got interrupted. And what do you want to do? You want to stop your work and go and pick the ice cream or whatever it is. First, you have to see who's there in at the door, and then you pick the ice cream. And since it's ice cream, maybe you want to keep it in the refrigerator, right? So you will do that. You will keep it in the refrigerator, and then probably you can resume your work. Okay. So this is how typically our day-to-day life would go with some interruption. Similarly, you know, we have interrupts in the OS. Okay, so OS also deals with the same way. For OS, a signal which makes process to stop its current task and proceed to execute handler for interrupting source. That means whenever it gets an interrupt, so what happens is it will suspend the application immediately to serve the interrupt, right? So it will stop the process. And then what it's going to do is it will save the context. Why you want to save the context? Suppose in our case, when we went, we came back and we resumed our work. Okay. Whereas in the computing process, we should know from where to continue, right? So to do that, we need to save certain context. What is the where was I? Suppose if you're reading a book, probably you want to bookmark it, or you want to know the book number or page number, right? And then you want to load and execute the ISR. Don't worry, ISR is nothing, just an interrupt service routine. That means whenever there is an interrupt, there will be some routine which will be executing, and it will finish its work and resume. Then we're going to resume the task, or you can say application. So that's how a typical interrupt works. And so this is a high level. Much more happens beneath. So hardware, there is a hardware interrupt and there is a software interrupt, right? So hardware interrupt is something which is triggered by hardware. And software interrupt is something which is triggered by software. We'll see that. What is software interrupt, right? So before that, we'll see what is system call. Okay. So we've been talking about interrupts. Now we'll see the system calls. System call is a programmatic way in which a program requests a service from the kernel. So you can see it's from the kernel. So that means if you want to have some request, I mean you want some service from the kernel, which could be any service, like here you want to know the time, or you want to send a packet, network packets. So network packets will be sent via hardware, so it has to go via kernel. So if you want to interact with the kernel, all you have to do is call system calls, right? So that is what it is. So requesting a service may include hardware related service like getting a system time, creation and execution of new process or application. So whenever I open one browser, so basically we create a new process, right? We create a new program, right? So we will see that what is process. So don't worry about it. And then it can be used for some of the communication, which we call IPC, which is inter-process communication. System call provides an essential interface between a process and the operating system. And system call can also be called kernel APIs. Well, logically, we are calling the kernel service and it is getting served. So you can call it, right? So let's see a working model to understand what the system call and how it works. Okay. So there is a user space and kernel space. Now I want to take a pause. Someone asked about the security question. So one of the way to give the security is via this. So there is a segregation. There is a kernel space and a user space. Okay. So user space has some limitation. They can't do anything. They can't access certain hardware. In user also you have certain mode like root mode and user mode. That is one thing, which is for the admin. Apart from that, from the hardware perspective, there is a segregation. So this is one way of achieving security. So suppose I log into a laptop, I can't just bombard with a lot of things. I can't just make it down unless I have a root access, because I have a limitation. I can't access the hardware directly. Okay, so that's why there is a segregation. So suppose user application wants to get something, some information from the kernel. And here in our case, it is a system time. Okay. So system time is in the hardware, right? So you can get system time from the network, which is again, or from the hardware, right? So hardware, you have a RTC. So you need to access hardware. So application can't directly access hardware. Rather, they will use a system call. Now, system call will in turn will call a software interrupt, and there will be some service routine which will get into the kernel mode, and it will call the appropriate device driver. Why device driver? Because again, there is a piece of hardware and there has to be a driver. Okay. So from top to bottom, from the application, the call is going to the system call, then it's going to the kernel, then it's going to the hardware by device driver. And what we're going to do, we're going to fetch the information from the hardware and we're going to give that, right? So this is how a typically system call works, and this is what the use of system call. So main advantage is, this is an kernel API, and this way you have a very good segregation. So there is you don't have a security problem. So most of you are very young, even I'm young. In my old days, we used to have a DOS, DOS environment. So in DOS environment, there was no segregation, and that had a lot of security problem. Uh, just, uh, just for a thought. Let's take one more example. Here, the user application wants to again do some time. You want to get some time. Here you have a real system call. So get underscore time. It's a system call. This will cause and software interrupt. So software interrupt is something which is triggered by software. So here it will do an int with x80 on Intel architecture. On x80 architecture, the x80 belongs to a system call. On part PC or maybe ARM, it's a different value. Okay. So once there is an interrupt, so there will be an interrupt service routine, and there will be a handler. In turn, you can just think that there will be a kernel equivalent of get underscore time. So here you have a user space system call, which actually got converted into kernel equivalent get time. And it will go and read and give the information. Right. So this is how a system call works. And here you again got a nice abstraction where you need not access the hardware, and you've got all your data. Okay, so now I'm sure most of you have used, have done programming and used library functions as well. And now we are seeing the system call. So what is the difference, when we say system call, when we say library function and a local function? Okay, so a library function is any ordinary function besides, in external, right? External to the program, because it's outside the program, it's not inside the program. For example, it's printf, right? We use printf, and we don't write a code for the printf. We just straight away use the printf, and it dynamically gets linked. Whenever we load our program, it dynamically gets linked. And some of the programs we may have to link statically. That's a different story. But dynamically, this thing gets linked. It's not part of your program. Okay. Whereas in system call, okay, system call is implemented in the Linux kernel. It's inside the Linux kernel, and there is a special procedure required to transfer the control to the kernel. That special procedure is the software interrupt, and the core code is inside. So that is what the major difference is. So we will see what is the local function here. Okay. So here, if you see in this slide, this first one is a local function, and I already have a local function inside my program. So whenever I'm going to call this function, there will be a direct reference to this function, right? Okay. So second thing is that there is a string copy. So string copy is a library function. So then there is a direct reference, but this is not inside the program. Okay, externally it's getting linked. So this function is external. What about system call? Okay, suppose I want to open a file. Okay, so if you want to open a file, you will call open system call. Why you want to have a system call? Because file resides in a hard disk. It could be USB hard disk, it could be a flash drive. So again, it's a hardware. So you need a kernel interference. Kernel need to you need to interact. So that happens in kernel. So at first look, they all look similar, but runtime behavior is different. Like as you can see, both a system call and maybe library function, they may look similar, but runtime behavior is different. So that's why it's very important to understand how the system call works and how to get maximum out of it. Let's see a few examples of system calls. I'm sure some of you have done Linux programming, have used it. Open, we already seen exit to exit a program, write to write some data on the file. Then signal, close, wait PID, get PID. Yeah, fork is something very important. So whenever we start a program, suppose I click a browser. Okay, so program is initiated and it starts. So fork is a system call which a bash or a GUI calls to create that process, to create that program. Okay, to make it run. And there is something called socket. Socket is again very important. Anything related to network. In fact, now we are all watching this webinar, and I'm sure there will be a lot of socket connection which are serving our webinar session. So I'll do one thing. I'll just stop, Jaykumar. I'll take some questions and then probably I'll proceed.
Yeah, there are good number of questions. Let me go one by one from where we left off. So there's a question from Lanvin De Souza. He's asking, to understand OS, do we need to start from understanding the PC architecture? Is that the starting point?
Not required. It's always good. I mean, it's like any game, right? Football or cricket, for that matter. I mean, suppose you want to pick bowling, probably you need not focus on keeping, okay? Because both could be different. Yes, if you want to become an expert all-rounder, maybe you have to learn everything. So if you want to learn OS, maybe you can pick the top approach instead of bottom approach, or looking at everything. For a starter, I would suggest take the top approach, like understanding the system, how the system call works, understanding how each resources are works, how the software part works, and then probably look at the PC architecture. So that is something hardware layer, HAL. So that depends on the individual interest. As I gave an example of sports, so where you can choose a various thing. So that is what it is.
Okay, all right. So that's what Lanvin, just to add what Hari has mentioned. One of the reasons why he's covering the system call library, how it works, is typically what even we do in our Linux internals module is a right way to start penetrating into Linux, right? So rather than taking a hardware where you might get overwhelmed, right? Starting with the software is, or rather starting from an OS system call is what a good starting point, right? That's what Hari is reiterating. That's a given view, Landin. Can you just confirm? And in the meantime, there's a question from Vishesh. He's asking, my CS friend, I think maybe computer science friend, once told me that our smartphones run on Linux OS, where Android is built on Linux. So just want to know if Android is an OS or something else, and Linux is core OS which runs on our smartphone. Basically, you wanted to know the connection between Android and Linux. Hari.
Okay, fine. Actually, okay, I'll do one thing. I'll go back to one slide. It's a good question. I'll go back to probably here. Okay. Okay, so that's a very good question. So again, so imagine this whole part is OS. You have your phone, smartphone. It needs a GUI part and as well as a management of hardware. So when we say hardware, you have your graphics, you have sound, you have dialing pad. That is also hardware and very important piece of hardware in the computer in the mobile, right? So what happens is, so this particular piece of software is a kernel. Okay, so this is what if you have a smartphone, the chances are this thing is a Linux kernel, whereas this particular part, okay, where it needs to interact with the application. So what happens is, so why we need an Android? So mobile environment is slightly different. There is a security issue. One is that, and second thing is resource. On my laptop I have a different resource, whereas on mobile I have a different resource, and as well as the scheduling. So probably you need to have some modifications. So the part which interacts with the OS, let's say, if you have done some basic Linux course, let's say your Bash, so you have Bash here. So in a different, in a similar way, Android provides its own Bash, okay, and its own GUI and CLI, okay. So as in a simple answer, this part will taken care by Android, and this part is a Linux kernel because this is already there, and this is something which is unique problem to a mobile. I hope that answers to that question.
Is it clear, Vishesh? Okay, okay. I think he already confirmed. Okay. So then there was a question about Linux, which already answered security. And then there's a question from Ashutosh Ranjan. He's asking, are you working on embedded hardware too, sir, or working on embedded software?
Okay, I'm not sure I got that question, but yeah, I mean, see it's an evolution, of a person as well. So so my work is mostly on the server side. I started with embedded, then moved to a server side. So in all those places there is a Linux, okay, Linux involved. So, but not only that, so we have something called firmware, so firmware, so can you imagine like USB controller? Suppose you have a USB controller, you have USB flash. There is a piece of software running inside the USB flash, USB. So that is called controller, So sometimes you may have to understand that as well. So that can be termed as embedded, And whereas sometimes we need to understand how the server works. So that is non-embedded. So answer to your question, it's both. It depends on the requirement. Sometimes you have to take both. But again, that was me. I have quite a good of experience. But to start with, you will be focusing on only one part because again, deviating too much may confuse you.
All right. Is it clear, Ashutosh? Ashutosh Ranjan. Then there are some more questions here. Um, okay, from Rishikesh again. So if I'm going to program a game, why should I use Linux, not Windows? I have heard jokes like games are programmed in Linux but only playable in Windows.
That's a good question actually. So again, it's more to do with the popular choice and economics rather than technical aspects. So it's very easy to not easy. It's you will make a very flawless code in Linux. So you have all the tools. So when it comes to game, I'm assuming you will have some basic knowledge. So what happens is in sometimes some of the games, right, which requires high intense graphics, you might need some GPIO. Some of those GPIO can be well understood in Linux as well as Windows, because some of the hardware vendors, they make sure both plays it does well. So as a popular choice, as an end user, your customer may be in Windows. So maybe you want to have that product in Windows. But for development to make it robust, you will have it in Linux. That is one question. Second is, suppose you have a gaming server, okay, not on the laptop. There are some games where actually, you connect, like NFS, Need for Speed, or few other things. I'm just giving an example, not saying that they use Linux. So some of the server driven, where backend there are a lot of processing. There will be one server who's doing a lot of processing. It makes sense to have a Linux rather than Windows in those environments. Whereas if it is an individual game, probably having only on standalone window makes more sense. So it's more of a requirement and popular choice.
All right. There is one more question before we proceed. There's a question from Nihar Savalia. The question is, can you please explain the difference between firmware and middleware?
Okay. I think it's out of the scope of today's session, but anyways, I'll try to explain. So in a nutshell, the firmware is, so suppose you have a server, you have, or your laptop or anything, iOS. Okay. So there is a piece of controller running inside your phone, inside your laptop. Okay. So, and that piece of controller needs a software. Okay. So basically, in a terminology friend, that is called a firmware, right? So let me go here, and I can just give you a high level answer because I don't want to get too much deviate. So suppose this is architecture, okay, and this is a motherboard, and chances are there will be some thing is running here, or there's a PCI controller or USB controller. Something will be running here, or if there is a device connected, so that device will have a firmware running, right? Why there is a firmware, why we call firmware, because that is not running inside our system. Okay, we are interacting with the software which is which is there in the device. So firmware typically means something can be changed as well. Firmware means it's not rigid, because we have something called ASIC, where everything is programmed inside the hardware. The problem with that is you can't change it. Suppose if there is a bug inside this chip, okay, small bug inside this chip, you have to replace the chip. Whereas if there is a small piece of software as well running, and if there is a bug inside that, probably you can just upgrade. Okay, so that is a firmware. Middleware in definition, it sits in many ways. Like here, a firmware can be a middleware, because what happens is when I'm interacting with one more hardware, so in between there is an abstract, there is an abstraction. So that can be defined as a middleware. Okay, and second is so that depends how the company is taking that definition strictly. In some of the case, we have a middleware where we have a firmware, and on top of it, so firmware will interact with the hardware, and on top of it you have a middleware, and then on top of it you have something for the user, where they can make some changes. So definition of middleware varies in some extent, whereas firmware has far more firm definition. So it's more of a definition and terminology. I hope that answers to that question.
All right, Nihar, hope that clarifies your question. One more question before we resume. I think there are many questions, but one interesting question that is coming from again Raghavendra is Linux is used in Apple phone. All people tell that Apple phone cannot be compromised. Is it because of Linux or iOS? Again, there's a lot of confusion, Hari, among people. Even though it sounds similar, right? People confuse between uh, Linux, Unix, iOS, or even for that matter, NetBSD, right? They're all entirely different flavor of things, but they kind of get confused. So can you throw some light on it?
Okay, so this is what various OSs. No, in fact, if you see this Linux logo and Android both are same. It just the interface is different, as I explained. So iOS is something which runs on. So it's an iPhone. You can say all the iPhone has iOS because they want their own variant. So Jagmar, if the question is related to security, that iPhone versus Linux, or in
No,
general the
in
OS.
specific to security, but in general, I'm seeing like, there's a confusion among people about, Unix, iOS, Linux. They all feel same.
Yes, so Unix, it's like a ancient name. So just to give a background history, so way back in 1970, in fact, there is a quiz also which has correlation with that. So way back in 1970, time, they faced this problem, the problem which we are discussing. So this piece of hardware, they had a very screwed OS. Mostly an embedded kind of OS. So then they came with a very good general purpose OS, which was a Unix, and slowly it evolved. It took a lot of time, and then in between there came a BSD, and BSD is something very popular because it comes with one more licensing, and people started using a lot of industries started using BSD. And there was in between there's something called Minix, thanks to Tannenbaum. I like his book. I read some of his books, Tannenbaum. In fact, the Linux, Linux revolts. I mean, he claims that his guru is Tannenbaum. So he got some inspiration from Minix as well. So Minix again, there is one more variant of OS which is same from flavor of Unix. Uh, then you have Linux. Okay, so Linux has evolved, and thanks to GPL, and Linux has evolved. So when we say Unix, BSD, Minix, and Linux, all are kind of similar. There will be a difference, obviously, but they're kind of similar. But when it comes to Windows, Windows and DOS, these are entirely different. And then you have Macintosh, Macintosh, the old days, on all the Apple hardware, it used to run. So that is about the OS. Maybe it needs another half an hour to explain various OS, so I will not get into that. One
All right.
interesting one
Yeah, good.
interesting is Apple versus Android, let's say. Okay, so again, since it's available in the public domain, I don't want to stick out my neck and claim one is far secured and not. Because it's not that easy, because what happens, it's like a race. At one time Android may be very secure, and at one time iOS may be very secure. Okay, but I personally, from my personal feel, that iOS in mobile is little secured, because what happens, it's again due to the policy, nothing to do with the, probably not much with the architecture. Policy is iOS does, iStore Play, they do a lot of certification. You can't, in Android, Google, I mean the Play Store, probably you can have a lot of application, and they also have a lot of certification. I mean, it's not easy to put your software. Whereas in iOS based application, there are a lot of testing and certification. They do a lot of rigorous certification. They won't let you. Suppose if I want to write one app for iPhone, it will take a while. Whereas for Android, it will be little faster. I mean, not because of the technical challenges, it as well as there's other process. So in that way, probably personally, I feel maybe sometime iOS is little, has more edge in terms of security. But again, uh, some other data may prove me wrong, because you have other, so security is a vast topic, and how you define security. There is something called security vulnerability test, so there are various security vulnerability tests. So based on that, you actually measure. Okay, so sometimes iOS scores well, in some benchmark, Android comes at par with iOS. So that's how it is.
Solid, Hari. Please proceed. I think there are still questions. We'll take it up depending on
Yeah,
time.
yeah.
I think we're all
So by the way,
okay.
I use iPhone for same reason. I just personally felt that iOS when I bought. I'm talking about some 5-6 years back, and I'm still continuing because you get used to it. So I felt that time it was secured. So now Android has solved a lot of security problems. Okay. All right. So I'll do one thing. I'll proceed. In case you have more questions, Jaikumar, you can just stop me anytime. Okay. So we will, okay, so far we actually covered what is interrupt, then we saw OS, a little bit on Android as well. Okay, so now we'll understand what is processors. Okay, by the way, it's not processor. Okay, it's a processors. Okay, and process states and process descriptor. Okay, so we'll see them one by one. Okay, we'll just look at the overview. So what is process exactly? Okay, so when we have a program, we compile and we get a binary, right? It can be exe file or it can be a.out, right? So a.out is a Linux format. Okay. So what it is, what exactly is a.out? So a.out is just a binary, it's just lying in the hardware. Okay. So which is a hard disk. It's passive, it's lying in the hard disk. It has instructions, but it's not running. Okay. Whereas if I run it, it becomes live, it becomes a process, it becomes a meaningful. So now it's inside, it's active, and it's inside the RAM, and its instructions are running. Actually, instructions are real instructions which are running in the CPU. Okay, and then the data, it has data, so data will be in the memory, and there will be few other resources which we'll see. So that's how, typical from binary. So here you have binary. When I load and run it, it becomes a process. So all the running, program, or you can say binary, when they're in the running state, or when they're ready to run, we call it process. Okay. So in that sense, the application, whenever we refer to an application, we say process. So application and process, in a way, you can say it's same. Okay. So let's look at close. Suppose this is a program, simple program. So what you're going to do is you might compile this and get a binary, right? So once you get a binary, you're going to load this. So what happens when you load and run? It becomes a process. So this piece of code will look something like this on your RAM. Okay, and actually, so there's something called stack space. So all the local variables and function pointers will be up at the stack. Okay, so that's the use of stack. It can grow and shrink, right? And then you have something called data segment. So all the global variables will be in the data segment. And you have something called code segment. So all these things, C code, which actually when it gets compiled, it becomes an assembly code, right? So that will sit here. Okay, so there is a section called C code. Then there is something called heap. What is this heap? Okay, so heap is again something can grow and shrink. And heap is nothing but we do a dynamic allocation, right? So whenever we do a dynamic allocation of memory, here in our case, we are doing 100 bytes allocation. So that will be, that will come from a heap region. So why we are discussing this? See, when we write a program, this is a program, right? But we should understand how that program will look. Okay, how that program is placed, so that we can design it better. So here you have a small program, but when we have a big project and we are doing, suppose, a lot of handshaking or system call program, we need to understand how that exactly will look. How this can there be a stack problem, or can there be a memory problem, and all these things. So that's about process overview. So let's see what happens when and or how process runs. So whenever I load, so there is a scheduler. What is the job of scheduler? Is to schedule. Okay, so scheduler will schedule that process, that piece of program to a CPU. So you have a ready state and you have a running state. Running state means something which is running. That means something which is using CPU. Okay, so here it will dispatch. The scheduler will put it in the running. And how it will put, on what basis it will put, there are various way, various method or algorithm. Like it could be based on priority, it could be based on round robin, it could be first come first serve, or there could be one more algorithm called shortest job first. So all these things are various things. By default, Linux uses round robin, which is far more easy and it gives far more fair share. In some of the real time, we might see priority, because priority is far better in real time environment. And there are a few other things. So that's about scheduler and process. Apart from that, you have interrupts, right? So interrupt is a reverse of scheduling. Okay, so what that means? So when there is an interrupt, let's say there is a timer interrupt. Okay, so what will happen is it will be reverse. From running, you're putting it to a ready state. Why? Again, we'll go back to our ice cream example. We are doing some work and there was a doorbell or knock, right? And we suddenly will interrupt. We got interrupted, and we will stop our work and we will go there, right? So that is what happens here. So when we get an interrupt, it again goes back to a ready state. So all these things are state. So why we are explaining? Because we need to understand there are various states, okay, and how the process can transit from one state to another state at what condition. Okay. Similarly, you have something called waiting. Okay. Why waiting? So imagine that you go to a railway station or airport. There you will be probably waiting for your time, return flight. Okay. So when they're going to announce, or your time comes on the board, there will be some something written that onboarding. So probably you can start the boarding. Okay. Similarly, in process also there can be various scenario where you want to wait. Probably you just want to sleep, or you may be waiting on a keyboard event. Like when I say keyboard event, same example. Most of the time you get some application where I say press continue, right? Press enter to continue, or press yes to continue. So basically it's waiting for the keystroke. Okay. So while it's waiting, that is a waiting condition. So it will go out so that other process can run. Okay. So those can be IO events or keyboard press, right? So it will go to a waiting condition. And once that event is completed, or suppose if I press a key, it will again go to the read heady queue, and then cycle will go. It will get scheduled. Uh, so how Linux kernel maintains this information, right? So let's take a simple example. Suppose in an office or in a company, there are a lot of employee, right? So you can treat employee as a process, in a similar sense. So you may want to keep all this information, right? You may want to keep information associated with each employee. You want to know the location, you want to know the state, and you want all this information centrally managed, right? So that we can easily access. And again, you want them to be frequently updated, always reflect the current status, and upon separation, or whenever there is an exit, or when they leave the organization, the records can be deleted. Probably you don't want to keep the record. Policy. So something similar happens in Linux kernel. So our objective is kernel must have a clear picture of what each task is doing, right? So that it can it can do scheduling, it can act accordingly. So some of these aspects are task state, what address space assigned to, and what files it is accessing, and so on. Okay. So kernel maintains a structure whose field contains all this information related to a single task. Means So that is where the kernel comes into picture. So kernel is something which is in the background. So it will maintain all the information of a task or a process. So if you're running a browser, it will maintain all the information, how long that browser is running, what is the memory usage, and what else it has. What is the priority. So these structures are called process descriptor, okay, or PCB, process control block. So let's see, how this will look in Linux kernel. So in a high level, this will have something like this: process state, process ID. We call it PID. So when you run a PS command, it normally show a name and process ID, right? So even in Linux or even in Windows, you can see some of these IDs when you look at the task manager. Okay. Program counters, registers, then memory information limits, and list of open files. So that we know, what files it has access to. Okay. So each of these information, are associated with the process, process state, program counters, CPU registers, scheduling information, which is very important, and memory management, information like, how much memory it has allocated, IO, IO status information, and many more. Okay. So something similar to, there may be an employee, but for kernel, all these are, human, they have life. So they want to, even Linux kernel want to maintain all this information, want to know how a task or a process is performing. Right? So let's see a live example, means how the program is. So here you have process one, which means a running program, which will have a stack, heap, data, and code segment. But there will be information, metadata information, and this metadata information is in the kernel space, right? So it will have all this PID, memory. Similarly, there will be a lot of applications. So each applications will have their own information. Okay. So these information are called process descriptor. Right? So that is what it is. So what we need to understand is there is something called process, and there is process address space. They have heap, they have data segment, and all these thing matters because let's say there is an environment. I'll give one example. Suppose you are running low on memory in Linux. Suppose you are running low on memory. What happens is there is something called out of memory, killer. It will going to kill the out of memory. So what happens is it will identify the application which is using a lot of memory, and it will check a lot of aspects, and it might even kill that application. So that is a very crude example I have given. There are many pleasant applications as well. Pleasant example like it will be using scheduling, proper scheduling, giving a fair share. So there are various aspects. So that's why we have to keep our program. We have to design our program such a way that we make kernel happy or our resources happy. So we covered, introduction, OS basic, why Linux is so powerful, introduction to Linux internals, and now we will see Netflix. We're not going to see Netflix. We're going to see Netflix Linux performance case study. Okay. So before that, probably, I'll pause a while. So Jay Kumar, I'm sure you must be having a lot of questions. So probably we'll take that question and then we'll proceed.
All right. There are a few questions, but before that, I'd like to quickly take a check with all of you in the call. Are you able to connect whatever is being presented so far by Hari? Like what makes Linux powerful? If you see, it all coming back to the kernel, how the scheduling works, how the system calls are there. Maybe you're not able to get all the technical details what is presented because it takes quite a while for you to get a grasp. In case if you've done a Linux internals module, for sure you would have able to connect better. But many of you would be in the earlier modules, say Linux or C, Linux systems or C or C++ module. But having said that, are you able to get a picture? Are you able to connect with what has been presented so far? Can I get some responses? I could see Sakiti, Abdullah, able to connect, Satek. Sachin, Ankit Kumar, Sahiti gives a better picture, bigger picture, she says. You know, then Raghavendra says yes, Ajay is saying yes. Manigandan. Okay, cool. That's the whole idea, guys. As Hari mentioned, it's a very vast topic. Trying to cover in 2 hours would be, definitely not feasible. Trying to put they say, elephant into a matchbox, right? It doesn't work. It's so fast, right? Okay, not 100%, but we came to know something, right? Right, and then having that curiosity for you to further explore is the motivation of this webinar, right? Even Hari's idea is not to give everything into all. It's not feasible, I mentioned, right? Just to give you enough pointers and enough viewpoints so that you can do that, right? And there is already a question about quiz. Okay, just getting live. Give me a few minutes. Once the talk gets over, I'll release the coupon code and then we can go live. Okay. So there are a couple of questions we can take, Hari. Okay, in the interest of time,
Yeah.
I think the question
Yes.
has
Yes.
come.
Yes.
Let me ask this from a student point of view. This is from Ashil Anthony Lewis. He's asking which are the books you suggest for a beginner to master Linux, OS, and kernel concepts. That's a book recommendation from your side.
Uh, I'm assuming those books are still there. Linux Beginner Programming, orally, that's the best book I have seen for Linux internals to understand. And for kernels, understanding Linux kernel is, like a Bible. There's no debate. Someone wants to understand that. And there is one book from Robert Love, and these are from when I was studying. I don't know whether they are still available, but I'm sure we will find an older version. There's a Robert Love from Linux internals or understanding Linux something. So Robert Love, and there's one more, understanding Linux kernel. Understanding Linux kernel from Rubini, it's an advanced book. So someone who is newbie, who just started, I won't advise them to, go right away. Probably, work on Linux system programming. There is a book on orally. I mean, Linux system programming or something. So I'll share that information to Jay Kumar. Probably, it's not on top of my mind. But I think those books are still there, orally books and other things. So those
All right.
are the
So we can add a table in the end of the slide. Anyways, we also circulate the slide deck as a part of the recorded video, which we'll share it
right.
with all the participants. Maybe you can add a table in the end of the slide so that they can.
Sure. That can be done.
And one more question from Drupajyoti Sharma is asking, what are the disadvantages of Linux? I mean, why someone during design may want to build a system or Windows rather than Linux? So what do you see as the disadvantage of Linux?
Yeah, disadvantage is, it's a very good question actually. Disadvantage is some of these, applications which are Windows specific application, it's very difficult to build on Linux. Suppose initially I was talking about, media player or sound player. Those were Windows specific. There were not many takers in Linux. And I'm sure there's again, some application which are Windows specific. Means more popular on Windows, and you want to make them in Linux. Sometimes they use Windows specific libraries. So you may not get those libraries. Sometimes you have to patch it. You have to take the patches, and you have to So let me give you one more example. So I'm going to cover something called perf, Linux perf. Uh, so it's a tool. Okay. So this tool is sometimes not readily available on Ubuntu because it may not be there. So you have to load and build and then run it. Whereas in Windows, you will get an exe. Most of the tools will be in exe format. Whereas in Linux, you may not get that. Okay. But as a smart user, as a smart developer, we should be able to figure that out. I mean, what is that missing? What is the library that is missing? And probably have that library. So that is the advantage, problem we face. I'm sure everyone might have faced. If they're not faced, then probably you have not, experiment, that enough. If you go and experiment in Linux, you will face one library missing or something missing, and then probably you will go and need to download that library. Either it will be in a depot or RPM format, or it will be a source. So those are the challenges, so those are very good challenge. Why? Because you will learn, you'll again learn, you will learn what library it's using, and you will know, okay, for this needs to achieve this, these are the libraries and it's not available, so let me get it. So you will connect, you will connect. Whereas in Windows it may be a black box for you. It will work, it will be easy developing some of these applications.
All right. I don't know if many of you heard that. Uh, Making something harder is where we learn, right? If everything is easy, right? Okay. Because often I've seen, Hari, what I've seen students many times in monthly meetings, they jack me up and then they wanted to take all easy way or, easier shortcuts, right? Quickly, rather give me or say, we don't, for example, Hari referred about orally books, right? Orally books are quite hard to digest, right? There is no, we want to study class notes and get the same knowledge. It doesn't work, right? If you want to get a real knowledge, you need to study, spend time, and that's not going to come so easily, right? Okay, it's good to see,
Correct.
you're driving that point as well, which we try to inculcate in our people. All right, I think we can proceed, Hari. We have another 10 minutes left. We cover the Linux,
Sure,
Netflix
sure,
part.
sure, sure. I think we'll make it fast. Yeah. So I think this is something which I'm sure some of the experienced people should get connect. Okay. So Linux, most of the companies they contribute, like Google, IBM, Huawei, Red Hat, and I'm sure I missed a lot of company name. But today we will, out of these examples, we will see Netflix. How Linux perf help Netflix get better performance, right? So, and how Netflix actually contributed back. You know, uh, so we will quickly start. Okay, so Netflix has this problem, of not only one particular company, even many company has this problem. So where they want to extract more from the hardware. Okay, so Netflix here, using a large cloud computing system. So they want to understand the CPU profiling. Like when you say CPU profiling, you want to understand what kind of, how much CPU each program or each function is using. I'm sure, while writing program, we don't think about it. Most of us, when we write a program, probably we are not worried how much CPU that going to take. Okay, maybe not, but we might have to, think. Sometimes when you go in the industry, we might have to think that way as well. And apart from CPU usage, you even have a memory analyzer. Why? Because again, while allocating memory, sometimes we will allocate some vague number. I mean, sometimes we will allocate a large piece of memory, whereas we might not even use it. So we should know, which function is allocating more memory and why. If it is legitimate allocation, it's really required, then probably we can let it use. Else, probably we have to do something. We have to do restructuring of it. Okay. So there are some tools available, and these are for for expert. But I think everyone is expert right now. Kind of question has been fired. So these are the tools which Netflix developed. So as I said, it's Linux is not only about using; it's about the contribution. Okay. So these are something which they developed, they used, they faced the problem, they identified the problem, they fixed it, and they shared it. Okay. So what is Linux Perf? Okay, so Linux Perf is a performance analyzing tool. Okay, this is also known as perf underscore event or perf tool. Originally, it's called performance counter for Linux. Okay? It's an old tool. I mean, it's not that new. Okay, so it's an old tool. It gives a lot of information. Like if you have used top, if you have not used, I will encourage that check the top. Tag top will give a lot of information, but top has some limitation. It can just provide a high level view, whereas perf can get inside, go inside because of the kernel availability. It understands the kernel. Okay, so it's again a tool, a command. Okay, and it comes with a few options. Like some popular options are perf stats, will give the statistics. Perf top, it's again similar to top, but it will give the CPU clock information, how that clock is. And then you have a perf report, so which will be, it will report the performance information. Okay. And then you have a record. Again, you can use it with various options where it will record or report. Okay. So we will not go detail into how to use it because it's again, it's an advanced topic. It will take 1 hour to cover it. So there is something called flame graph. So this is what you're going to get, flame graph. So flame graph is something like this. Okay. So this is the outcome of your perf. So I'm sure you all may be thinking, what is this? What exactly is this? Or it may be looking like a matrix. Some of you have seen this movie Matrix, where everything becomes 0, 1, or little complicated. So don't worry. We will take some five minutes, and I'll explain you what exactly is this. This is little advanced, but not something very difficult. Okay. So this is what typical flame graph is. I'll just give you some time. All right. So if you see here, these are all functions, right? These are all functions. So it's very difficult to get initially. Don't worry. So these are all functions. And so here there is an example of Java. Okay, and there is a Java start. So if those who have used Java, so there will be a Java start, inside it will start that. It's a runtime Java, and then then Java will serve. Okay, so this diagram gives what is the CPU usage. If I put my cursor, it tells this particular piece of function has taken 72%. Okay, and if I go up, you will see few more information. So more the width is, the more the percentages. So why we want to know? So we want to know where the bottleneck is, where the problem is. And if you see here, right, something interesting. Here you see sys functions. So this is what the system call is. There is some write here, and if you go up, it's not right. There's a kind of write, but if you go up, there's actually a socket, TCP. Okay, so again, it might sound advanced, but don't worry. These are all kernel calls which are related to network. Okay, so if you see, there are some TCP calls, and then there are some IP calls because you have internet protocol, and it talks about various calls, and it talks about the percentage. Okay, so why it's important? Because this way we will know which particular function is taking more CPU, okay, or where the problem is. Suppose we want to solve some performance problem, okay. So this is something very not. It is a unique problem. I think even in Windows and everywhere you have this problem. But thanks to Linux, it solved it. And nowadays, I think even Windows has this kind of graph, and few other has this kind of graph. I'll just explain. I agree that it may not be very straightforward. So I'll just try to explain how this thing is. Uh, okay. So you can just imagine this is your program. You have main. Then you have a one function, local function. So please mind that a function may call one more function. So that is what is happening here. A function will call one more function, okay, and that will in turn will call one more function. So there is a chain of functions. So that's how it is. So here you start, and one function is calling another function is calling another function. So at beginning it might look something very vague, but once you take some time, you will understand. And believe me, when I was working on it, it took me a while to understand a few things. So, so, so this is how things are. The one function is calling, there is one more function. So that's why you see a lot of, a stack of functions. And then on top of it, you have a system call, and now right? So there's a system call, you saw something like sys open, and there was a sys write, okay? So I think now you can say, yes, I have seen this. So this is, a tool. Basically, these are the tools which we use. And while we use, we need to understand few things, how the call is, how the thing is. And this is how Netflix solved some of its performance problem. Okay. So apart from that, we have same way we can have a memory, analyzer where you can check the memory usage. Same thing, where it's giving the CPU, it will give the memory in terms of percentage. So you have few tools like Valgrind, you have Proc as well, and there are some libraries. But something which is very interesting, again it's advanced, something which used in industry who wants to do some performance tuning. It's the extended BPF. So extended BPF is a Berkeley packet filter. Okay, so this will be give something similar to your performance tool. So this is for the memory. And I think with this, I can conclude today's session. So it's over to you, Kumar.
All right. Yeah. Thank you, Hari. Give me a minute. Let me.
Sure.
So thank you very much, Hari. I know it's not an easy topic to put across in a matter of 2 hours. That to starting with fundamentals of Linux, and then moving on to system calls, and then coming back to some real-time use case like the Netflix performance issue, and how the system calls and tracing the system calls helps you to basically optimize and solve some of the problems. I understand that. Okay, but as I mentioned few minutes back, the idea of this particular webinar is to connect you guys with the big picture. Students, especially Emertxe folks, right? They go through 3 levels of Linux modules. One is the
Correct.
Linux system where they learn about the commands and the shell scripting, and then subsequently they get into the Linux internals where they learn about the processes, threading and IPC and stuff like that. Then they move on to the embedded Linux part of it, right? Okay, the idea of this particular talk is to give a view about how this is being used in the industry, and some of the points that if you see, my major takeaway from today's talk from Hari was how the foundation matters, the foundational problem solving skills, being good with C programming, ability to explore, ability to solve the problem. Even if you heard what it does on a daily basis, it's all about problem solving and basically dealing with customer challenges. That's what it's all about. Even though the principal engineer, they may be technically senior people, you're all expected to solve problems, right? So I think those are all some of the key takeaways that you can understand. And then subsequently, Linux is a very vast topic. You can start exploring one by one, and then probably get better at it after a few years down the line. Okay, so that's what would be my learnings. Can I get some quick feedback? How did you find today's session? Of course, we'll talk about quiz. You can see there is a slide already. Diana is telling great session, thank you. Then Kamakya is telling informative. Thank you for your wonderful presentation. I admired your presentation skills and PPT. Thanks. Ajay says very useful. Says Afsal. Interesting, sir. Learned a lot. Says Satik. Any more feedback? Great session. Says Abdullah. Good session. Says Sakiti. Informative session. Says Manigandan. Amazing session. Thank you so much. Says Harshraj. It was awesome. Says Chinni Banu. Are you able to see that connection, guys, with what you're going through in our course? Since majority of you are our students, it was awesome, says Chinni, and then great, says Mohan Krishna. Good session. I learned a lot, says Venkatesh. I've developed some interest about Linux. Yes, Drupajyoti. Linux, as I said, it's a long journey. If you start developing interest with this particular talk, that's something really great. You can further build on it for next 20 years. What Hari has built, and even I'm sure you will agree. But working for close to 20 years, he's probably learned only a piece of Linux. Right? There's so much into it, right? I understand little bit, says Ravi. Yes, I learned a lot, specifically the insect working, says Harshraj. And then, where to attempt the quiz. I think there are a lot of questions, so let me open it up. You can see here that the quiz, you need to put up a code there. Guys, please copy, or rather I would add it in our handout section also, because without that particular quiz code, we will not evaluate, because we don't want anyone and everyone to use it. Okay. Uh, I'm just uploading a coupon code in the handout section also. It is just getting uploaded. You can see a file there, coupon code.jpg, or you can see in the screen. Okay, please ensure you note down the coupon code. That's the first thing. And then you can come to our Instagram page, folks. Like people know, in case if you are not aware, Emertxe, instagram.com/emertxeit, and you can just click on the story. You can see that there is a story. If you click on this, already the quiz is live. You can see, right? Welcome to Linux quiz, right? And if you see that the first question is to enter the coupon code, okay, please ensure you attend that, and then subsequently you can answer the quizzes, right? So in the coming week, our team will evaluate, and then we will announce winners who answer the maximum number of questions, right? And winners will get some goodies. And people who attended the webinar today will get participation certificate. We will email you in form of soft copy in the coming week, like we always been doing, so that you also feel motivated. And there are also questions about Vikas Patil. It includes the confidence. Thank you for a wonderful session, says Rashmita. Looking forward for more such sessions, says again Rashmita. We will bring in, as I said, we are kind of calendarizing the first Saturday of every month. We will use for masterclass webinars, so that we can see today is the first Saturday of April. So definitely by first week of May, we will have the next masterclass webinar. The topic and the speakers we will announce. Watch out for the social media. Watch out for our Google groups, WhatsApp groups. We are trying to reach out to as many channels as possible. So feel free to forward among your friends and your fellow colleagues who may be interested in this topic. Okay. So with that note, thank you very much for all of you who attended today's webinar. So thank you very much, Hari, for spending your quality time. I know it's a Saturday, 9 p.m. You have a lot of other priorities, coming and sharing these type of insights based on your real-time experience. So it's been a pleasure having you as a part of today's Masterclass webinar. So thank you very much for your time, Hari. I know still a lot of questions coming in. We're not able to answer everything because we need to time out. It's already 9:05. We'll try to get some of them answered offline. Okay. So thank you very much. Once again, happy Ugadi to all of you, and see you in the next Masterclass webinar. So thank you, students, interns, all the participants. Harry, once again, on behalf of Team Emertxe, and see you in the next Masterclass webinar. Okay. Take care. Bye.
Thank you, Jaykumar.